Okay, guys, previously we talked about linear functions. We talked about domain and range and things like that. If we stick with the linear idea, a lot of times when you're dealing with linear functions, there is a connection between individual points on the line. Now, all a line is, as you see here, all a line is a whole bunch of individual points. So instead of just drawing several little dots like that, we just go ahead and connect the whole set of points. There is a relationship between each point, and that relationship is called the slope, or measure of steepness. You may even know it as rise over run. Slope actually has a definition. It's the ratio of vertical rise and horizontal run. And it's also called a rate of change, using it in real world applications. Also, it's called a gradient as well. You may have seen the sign on the side of the road if you have ever traveled, and it looks like a hill or something, and it has a truck on the side of it and it's going uphill, or another one where it's going downhill. That's basically telling you that it's steep. It's about to get steep uphill or going downhill, depending on which direction it is. And that's all a measurement of slope or gradient. And so the idea is today we're going to focus on a concept of linear functions called slope. And so most of us have seen it, know it. Slope is a universal symbol for slope, is M. And like I said before, we can call it a rise over run. You can use this little chart here. It becomes very handy. The numerator or top deals with going up or down. As always, that's the rise, and the bottom or the denominator deals with left or right. So it's a measurement of vertical rise and horizontal run, if you want to call it that. This is what you would use in the series of 2 points. Now, one thing I always like to specify is the slope is not a point. We don't want to use a point and call it the slope, or vice versa. The slope is a ratio, a measurement between 2 points. Now, there's 3 ways to find the slope, and we're going to talk about all 3. You can look at a picture or a graph and find the slope. You can look at 2 points or the slope formula, and you can look at an equation. We're going to talk about all 3. And again, this is a relationship between 2 points in a linear function. All right, so it's based on the linear function where we ended our last notes. So how do we find the slope when we have 2 points? And so here we go. Whenever you have 2 points, this is a generic point here. Every point is x first, y second, we know. Every point is x first, y second. So the 1s is for the first point, the 2s is for the second point. That's all that means. First point, second point. And so you can flip them around. This could be the first point, that could be the second point. Now, this is very simple. What you're going to do is substitute in for each one of these variables the numbers where they belong. So for example, something I like to do with my students is this. I like to tell them that this is the x and the y in the first point. That's where the little ones are. This is the x and the y in the second point. That's what the little 2s are. And if you're confused, I tell them to draw this out. This is like our game board. This is where we're going to play. We have 4 spaces here that gets 4 numbers, and we have 4 numbers here. According to the map, y2 goes first in this position. So y2 is 3. Then it says y1 is next. This is y1, so negative 3. Then it says x2, which is 3, and then x1, which is 6. Now, the reason I do that is because sometimes people forget to do this. The mistake that they will do is just say 3 minus 3, which is incorrect. That's not what this means. Whenever you have a minus a negative, that equals a plus. So this is really 3 plus 3. And down here, you have 3 minus 6, which is negative 3. And 6 over negative 3, which equals... Now, this is several steps. You don't have to go through all of that. You can go from here to here if you choose to. But this is just showing you how you get that. Now, some people say that shouldn't it be a fraction like rise over run? Whenever you have slope as a whole number, don't forget that you can always keep it over 1 or put it over 1, and it still has the rise over run relationship. It's still a ratio, and the word ratio, of course, means fraction. Comparison of two values in a fraction form. So I'll work this one out as well. M equals -1. That's y. -1. Then -7 over 2. And so I get -1 minus a -1. Again, that's the same thing as -1 plus 1 over -9. Now, -1 plus 1 is 0. Anytime you get 0 on the top, your slope is 0. Anytime you get 0 on the top, your slope is 0. Number 3. M equals -2 minus 9, 4 minus 4, and you get M equals -11 over 0. Whenever you get 0 in the bottom or the denominator, that means your slope is undefined. Oops, that's ED. Alright, so that's how you find the slope using 2 points. Alright? Now, the next way we need to talk about finding the slope is finding the slope whenever we're given equations. Now, we'll talk about this in the future a little bit more, but the idea is that we need our equation in slope-intercept form, where M, or the number in front of the x, is your slope, and B, the last number at the end there, being added or subtracted, is your y-intercept. Okay? So, we're not necessarily caring about the y-intercept today. We're only interested in being able to take our equation and move it around in order to find the slope. And so all you have to realize or remember is you want to get y by itself. I may not work all these out for the sake of the time on this video, but you should write these examples down. But what you want to do, for example, on number 1, is I need to solve for y. Whenever x and y are on the same side, the first thing you need to do is do the opposite, or make x go away to 0. That leaves me with 4y, and since I want it in this order, slope-intercept, y equals mx plus b, since I want it in that order, I'm going to put the -3x first, plus 12. You say, where'd the plus come from? The 12 is positive. So I just rearranged the order. Instead of writing 12 minus 3x, I wrote -3x plus 12. Next, in order for me to get the y by itself, that's what solve means, you divide both sides or everything by the coefficient in front of y. In that case, that leaves me with y equals, you don't change that to a decimal, -3x over 4, and this becomes plus 3. This is not your answer because the only thing I want to know is the slope, and the slope in this particular problem is -3/4. I'll do another example here. I'll subtract x. Whenever x and y are on the same side, you move that around and you have -y. Now, a lot of people make the mistake here because they'll drop down a positive y. If this is a minus y, it needs to come down as a minus y or a -y. Now, how do I make this become positive? I can't leave it like that. You're right, even though I didn't hear you say anything. You divide everything by -1. So we get y equals x minus 5. So dividing or multiplying by -1 only changes the signs of what you're working with. Now you can work those 2 examples there. Now the next way to find the slope is by looking at a graph or a picture. And these are simple. What you need to remember in order to find the slope using a graph or a picture like what you're looking at now is this little friendly little guide map here. Basically, whenever you count up or down, that number goes on the top. And notice what sign goes for which direction. And whenever you count left or right, that number goes on the bottom or your denominator. And again, notice the sign. Each direction has a sign. Now, what you have to do first, though, is find 2 of what I call important points. Now, they actually have a name. I forgot what the mathematical name is. I just found it out last year, but I forgot it. So I call them important points. Let me show you what I mean by an important point. If I zoom in here on number 12, notice that right here, the line crosses in the corner of the box. And right here, it does not cross in the corner of the box. This right here is what I call an important point. In order to find the slope of a line, you have to find two of those important points. So here's one, and there's one right here. So there's two, and then there's a third one. Your line may have many, but you only need two. And so how do you find the slope? Well, what you would do is put your fraction down. Say I start from here, and I count to this point here. I'm going to start here, and I'm going to count up and then left. Counting up goes on the top, so I count up 1, and it's positive. Why? Because going up in a positive direction. You restart your count as you move to the left. So I went up 1, that went right here, and now I count to the left. 1, 2, 3, that goes on the bottom. However, I went in the negative direction, so that's a -3. Or what if I started here and I counted to the left first? I count to the left, 1, 2, 3. That goes on the bottom and it's negative, and then I count up. I still get the same thing. The direction that you count does not determine if the number goes on the top or bottom. The direction counts for the sign. It's where you count. Well, I probably said that wrong. If I count up, that tells top or bottom. If I count down, that counts for top or bottom or numerator. If I count to the left or to the right, that's for the denominator. What about this particular point if I switched it around and I started from here and I counted here? I should get the same thing. Starting here, I'll use a different one. M equals, counting to the right, 1, 2, 3. That number is positive, but it goes on the bottom because I went in the right positive direction, but I counted to the right. That also goes on the bottom. Then I count down 1. That's on the top, because up and down goes on the top, and that's negative. So, are those two different? Is -1/3 different than -1/3? No, both of those are exactly the same, so it does not matter. The slope is uniform throughout the whole line. As you can see there, that answer is already there. If we shift over to look at number 1 here, or excuse me, number 11, you'll see that everywhere on here, there's a place where this line intersects in the corner. So if I count up 1 and to the right 1, that's 1/1, and that equals 1. What about if I started here and I wanted to stop here? It don't matter, just pick 2 points. So I count up 1, 2, 3 over 1, 2, 3. 3 over 3 is 1. So everything will be 1 in a situation like this. Now, the last thing that we need to discuss is the first thing I had up here. This is just a quick reference. Anytime you see a vertical line, the slope is undefined. Anytime you see a horizontal line, the slope is 0. Always. These are always. You don't have to have 2 points to figure these out. You just should know that. Anytime from left to right a line goes up or rises, that's a positive slope. I may not know the number. Anytime it goes down from left to right, that's a negative slope. I may not know the number. So let's check that real quick. Time is running out. So the answer to this one is positive 1/2, as we see there, and it's going up. Now, how do we prove that? Here's an important point. If I count up 1, then I count to the right 1, 2, that's 1/2. Notice that this is -2 as the answer to number 15. How do we get -2? If I start here and I count down 1, 2, that 2 is on top and it's down, so it's negative. And then I count to the right 1. So what's -2 over 1? That's -2. So in summary, we have 3 ways to find a slope. The 3 ways of finding a slope are a graph, 2 points, and an equation. And I showed you all 3. If I went too fast, guys, you need to go back through and slow it down and pause. If you have questions, write them down for me. Bring your questions to class, and then we can discuss them. All right. Peace.